In this lesson, we are going to cover exponents. Here we are. So let's start off with some vocabulary. This right here is 5 to the third. Now, the big number is called the base. And that small number, this number right here, that has two names. You either can call it the exponent, or sometimes it's also called the power. Oh, that's a weird looking W. Sometimes called the power. So the way exponent works is this is called 5 to the third power. And what that means is it's repeated multiplication. So what I'm doing is I'm taking 5 and I'm multiplying it by itself 3 times. So that's 5 times 5 times 5. By the way, we call this the expanded form. The expanded form. So if you have an exponent, let's say you had, 4 to the 6th power. What that means is 4 times 4 times 4 times 4 times 4 times 4. I think that's 6 times. 1, 2, 3, 4, 5, 6. Yeah. So 4 to the 6 means 4 times itself 6 times. All right, let's get back to our 5 to the third power example. So what does 5 to the third power equal? If you type that in a calculator, what would you get? You wouldn't get 15. You would get 125. Because, let's think about it, 5 times 5 is 25. And 25 times 5 is 125. So we call that 125, we call that the value. So if they ask you for the value of 5 to the third, you would say the value is 125. If they ask you what is 5 to the third, can you write it in an expanded form? You would write 5 times 5 times 5. All right, how to read powers. So there are lots of different ways you can read this. You can read it as 8 to the second power. Sometimes it's written as 8 raised to the power of 2. Or the 2 has a special name. It's also known as 8 squared. So the second power has a special name. It's also referred to as 8 squared. Let's look at this one. This is referred to as 5 to the third power, or 5 raised to the power of 3. And the third power also has a special name. It is called 5 cubed. The next one is 3 to the fourth power. 3 to the fourth power. Or we can also read it as 3 raised to the power of 4. To the power of 4. Now, there are other ways to read it. You could also say 3 to the fourth, or this could be 5 to the third. These are kind of other names for it. And 3 to the fourth power does not have a special name. There's no special shape. It's not like a rectangle. The fifth power also doesn't have a special name. Sixth power. The only two powers with special names are 2 and 3. Now, you may be wondering why 8 to the second power is known as 8 squared. I can probably explain right here. So, let's say I told you that there was a square, and one of the side lengths was 8. Do you know what the area of that square would be? Well, to find area, it's the base times the height, or the length times the width. And because it's a square, both the sides are the same, right? This side and that side, they're both the same. So it would be 8 times 8. 8 times 8. What's another way of writing 8 times 8? 8 to the second power. That's why that's called 8 squared. Now you may be wondering, okay, what about cube? Well, you probably already figured it out. In order to find the volume of cube, what you do is, let's say one of the side lengths is 5. To find the volume of something, you multiply the length and the width and the height. So if one of the side lengths is 5, guess what? Because it's cube, all the side lengths are the same. So how do you find the volume? It would be 5 times 5 times 5. And what's another way of writing 5 times 5 times 5? 5 to the third power. That's why 5 to the third power is known as 5 cubed. All right. Anyways, let's get to some easier stuff. Directions. Rewrite each expression using an exponent. What's 7 times 7 times 7 times 7 times 7? Written in exponential form? Well, that is 7 to the 5th, because there are 5 7s being multiplied together. 3 times 3, that's 3 to the 2nd power, or 3 squared. 0.2 times 0.2 times 0.2 times 0.2, that is 0.2 to the 4th power. 2 to the 5th times 2 to the 5th times 2 to the 5th. That is going to be, well, actually, let me show you what it's not. You may want to write this down. It is not going to be written this way. It's not written 2 to the 5th to the 3rd power. It's actually going to be written like this. 2 to the 5th. Well, let me explain why. Because if you read this, you might be thinking, oh yeah, this would just be 2 to the 5th times 2 to the 5th times 2 to the 5th, but that's not true. What this is actually saying right here is 2 times 2 times 2 over 5. So how do you write 2 to the 5th times 2 to the 5th times 2 to the 5th? Well, if you want to do that, you're going to have to use a parentheses. So we want to use parentheses around it. And that is how we write 2 to the 5th times 2 to the 5th times 2 to the 5th, or 2 to the 5th to the 3rd power. All right, let's try the next ones. 4 times 4, that is just 4 to the 2nd power, or 4 squared. 12 times 12 times 12, that's 12 to the power of 3, or 12 cubed. 3.4 times 3.4 times 3.4, that is 3.4 times itself 3 times, so 3.4 cubed. And finally, 5.7 times 5.7, that is 5 over 7, and we have to put in parentheses, and we put the little 2, the square, right there. All right, let's take a look at the next example. It says, find the value of each power. 3 to the 2nd power is not 6. It is 3 times 3. And what is 3 times 3? 3 times 3 is 9. What's the value of 2 to the 5th? It's not 10. It's not 25. It's 2 times 2 times 2 times 2. Now you can grab a calculator out, and if you did that, you would find out that the answer is 32. Because 2 times 2 is 4. Times 2 again is 8. Times 2 again is 16. Times 2 again is 32. 10 to the 3rd power. 10 times 10 times 10. That is 1,000. 10 to the 6. You know what? I'm not going to write it all in expanded form. I'm just going to write the answer. If you put it in a calculator, you'd find that the answer is 1,000,000. By the way, there is a trick with tens. It's, here's the trick. You see the little power right there, 3? That's how many zeros there are right here. 6th power, 10 to the 6th power, guess what? It's got 6 zeros. So if you had 10 to the 8th power, it'd be 1 with 8 zeros next to it. Anyways, just a neat little trick. 12 to the 1st power is just 12. 1 to the 8th power, it's 1 times 1 times 1 times 1 times 1. It's 1 times itself 8 times. What happens when you multiply 1 times itself 8 times? You end up with 1. It's not 8, it's 1. Number 15, 0.2 times 0.2 times 0.2, and a lot of people are like, oh, that's just 0.8. It is not 0.8. If you type it in your calculator, guess what? You're going to find out that the answer is 0.008. Try it out yourself if you don't know. Number 16, many of you probably cannot type in 4/5 in your calculator. Can't type in fractions, but that's okay. You don't need to, because 4/5 to the 2nd power is just 4/5 times 4/5, and I bet many of you can probably do this in your head. You ask yourself, what's 4 times 4? 4 times 4 is 16. And what's 5 times 5? It is 25, and that is our answer. You may be asking yourselves, wait a minute, Mr. Lee, before you boxed it, why don't you see if you can reduce first? Well, here's the deal. If you can't reduce the fraction on the inside, guess what? You will not be able to reduce this answer either. So, assuming you already reduced this fraction on the inside, you don't have to worry about reducing this. All right. Next one, 1/3 times 1/3 times 1/3. That is going to be 1, not 1 over 9, but 1 over 27, because 1 times 1 times 1 is 1. 3 times 3 times 3 is 27. Last one. This is challenge, but it's really not much of a challenge. This is saying 2 to the 2nd power, which is 2 times 2 over 5. And what is 2 times 2 over 5? It is 4 over 5. All right, let's go to the second page. the zero product property. The zero product property says the value of any number, x0, except for 0, raised to the power of 0 is 1. So let's jump to these questions, and I'll explain how that works. So 5 to the 0 power is 1. 28 to the 0 power is 1. 3.7 to the 0 power is 1. 3 over 4 to the 0 power, guess what? It's 1. And 1,000,005 to the 0 power, still 1. Those of you curious, why does that work? How does that make any sense? Why isn't the answer 0? I'm going to kind of do a explanation. So, math is all about patterns, and you can see this pattern with these numbers right here. It starts off with 2 to the 0 power, and it goes to the 2 to the first power, 2 to the second power, 2 to the third power, and as you can see, every time this power goes up by 1, you add 1 to the power. What happens to the value on the right? Well, let's start off with something we know. We know 2 to the first power is 2. 2 to the second power is 2 times 2, which is 4. And 2 to the third power is 2 times 2 times 2, which is 8. 2 to the fourth power, guess what? That's 16. So how am I going from here to here? And from there to there? Well, you times it by 2, right? 2 times 2 is 4. How do I get from 4 to 8? You times it by 2. So if I look at the powers, it's like, how do I get from 1 to 2 and 2 to 3? You're adding 1 to the power. And every time you add 1 to the power, you multiply by 2. If you look at these right here, let's start at 3 to the first power, that's 3. 3 to the second is 9, and 3 to the third is 27. How am I getting from 1 to the next? Well, if I go from here to here, it's times 3. If I go from here to here, it's also times 3. And then same with the 5s. You times it by 5, you times it by 5 again. All right, that's all well and good. How do we get 5 to the 0 and 3 to the 0 and 2 to the 0 equals 1? Well, let's work backwards. Let's look at the powers. If I go look at the powers and go backwards, how do I get from 2 to the third to 2 to the second, and from that to 2 to the first, and from 2 to the first to the 0 power? Well, you subtract 1 from the power. So 3, then 2, then 1, then 0. 3, 2, 1, 0, 3, 2, 1, 0. Okay, cool. So as you're subtracting powers, which is the opposite of adding powers, you're going to do the opposite. How do I get from 8 to 4 and from 4 to 2? Well, to get from 8 to 4, if you divide by 2 instead of multiplying by 2, 8 divided by 2, that will get you 4. If I divide this by 2, will I get 2? Yes. And so we're like working backwards now. So go from 8 to 4 and 4 to 2. How do I get from 8 to 4? Divide by 2. How do I get from 4 to 2? Divide by 2. How do I get from 2 to the 0 power? Divide by 2. And what's 2 divided by 2? It is 1. Same works over here. 27. If I divide by 3, I get 9. If I divide that by 3, I get 3. And what do I do there? I also divide by 3 again, and I will get 1. So that's how the zero product property works. All right, let's get to some of the challenges. Find the missing exponent or power. These are actually pretty simple. 27 is 3 to the what power? How can we figure this out? Well, if you had a calculator, it's pretty simple. Is it 3 to the first power? No, 3 to the first power is 3. Is it 3 to the second power? Which is 3 times 3. No, that's 9. Is it 3 to the third power? 9 times 3 is 27. So yes, it is 3 to the third power. So the question mark is 3. 3 to the third power. Or actually, let's just write the whole thing. It is 3 to the third power equals 27. The 25 is pretty simple. 9 equals 9 to the what power? It's 9 to the first power. And finally, 64 is 2 to the what power? Well, it's 2 to the first power is 2. 2 to the second power is 4. 2 to the third power, oops, not 2, 3. 2 to the third power is 8. 2 to the fourth power is 16. Oh my gosh, I just wrote 4, not 2. 2 to the fourth power is 16. My goodness. Is it 2 to the fifth power? No, it's because 2 times 16 is 32. And if I multiply that by 2 again, I will get 64. So how many 2's did I just write down? 1, 2, 3, 4, 5, 6. Oh, 64 is 2 to the sixth power. So that question mark is 6. Let's take a look at finding the missing base. This one is really difficult. What you're going to have to do is something called factoring, which is sometimes people call it Math Mountain. What two numbers multiply get us 81? I say 9 and 9. So if I multiply 9 times 9, 9 to the second power, that equals 81, but it's something to the fourth power. What number am I multiplying by itself 4 times to get me 81? Well, let's break down 9. 3 times 3 equals 9, and this is also 3 times 3. So at the bottom of my factor tree, or of my Math Mountain, I have 3 times 3 times 3 times 3. And guess what? If you do 3 times 3, that's 9. Times 3 again, 27. Times 3 again, you get 81. So if you multiply 3 4 times, you will get the answer. So that's the missing base. Let's try that with 32. What can we divide 32 by? Well, 32 is, I guess 4 goes into 32. We can say 4 and 8. 8, 16, 24, 32. Yep, 4 and 2. Now that doesn't quite help us because it's what number times itself 5 times. So let's break up 4 into 2 and 2. And then 8 can be broken up into 4 and 2, and then 4 can be broken up into 2 and 2. If you look at the bottom of each mountain, the base of each mountain, let me use my highlighter actually on this one. It's these numbers right here. We multiply 2 times 2 times 2 times 2 times 2, that's going to get you 32. So we now figured out what it's 5 2s, which is what we have right there. So it is going to be 2 to the 5th power for that one. Number 29. Ever wonder why there's so many bunnies in Ladera? If the bunny population doubles each month, how many bunnies would there be after 6 months if you started with 2 bunnies? Well, if you start with 2 bunnies, that's 0. After 1 month, you multiply by 2. And if you double it again in the 2nd month, so this is the start, that's 0. First month, after 1 month, you multiply by 2. After the 2nd month, which will get you 4, right? After the 2nd month, multiply by 2 again, and that gets you 8. 3rd month, 16. 4th. Actually, that's not 0, that's 1. So 2, 4, 6, 8. Oh, I wrote 4 again. Instead, I should have been writing 2. Give me a second. I am just kind of making sure everything looks good. So 16, that is going to get us 32. And then, let's see, so that's month 1, month 2, month 3, month 4, month 5, and then we have to do month 6, which gets us 64. So we would have 64 bunnies by month 6. So yeah, first month you start with 2, then it goes up by 2 every time. All right, let's, sorry, just get rid of that mess. Let's go ahead and go to the last 3, which are very important. We want us to circle the equivalent expressions below. Well, what can be helpful for us is to write this out in the different ways we know. 2 to the 5th power is the same thing as 2 times 2 times 2 times 2 times 2. That's the expanded form. And if we wanted to find the value, that is 32. So we know A is definitely equivalent. 2 to the 5th power does not equal 10. It's also not the same as 2 times 5 because 2 times 5 is 10, and so that's not correct. 2 to the 4th times 2, well, let's think about it. 2 to the 4th is written like this, 2 times 2 times 2 times 2, right? And you're multiplying that by this 2. So if I asked you to read this for me, you would say, oh, this says 2 times 2 times 2 times 2 times 2. Wait, you're multiplying 2 5 times, which is the same as this. And if you multiplied that out, guess what you would get? You would also get 32. So look at that. This also is equivalent. And we know that E is equivalent because there it is. We wrote it down. Let's look at 3 to the 3rd. 3 to the 3rd can be written as 3 times 3 times 3, which is not 9. It is 27. So we already discussed that this 3 to the second times 3 is just 3 times 3 times 3, which is the same as what's above, and if you multiply that out, it would be 27. This one, 9 times 3, what is 9 times 3? It's 27. Oh, so that's also equivalent, technically. 33 equivalent? No, 33 is not equivalent, but 27 is, and 9 is not. Let's take a look at 10 to the 4th power. Let's write it in expanded form, 10 times 10 times 10 times 10. And in the value is 1,000. So we know 104 is not right. Wait, not 1,000. My goodness, what am I doing? Not 1,000. It's 1 with 4 zeros, 2, 3, 4, 10,000. There it is. You may be thinking 100 times 100. Well, isn't 100 times 100 10,000? It is, so therefore, it is equivalent. 10 to the second times 10 to the second, well, that's just 10 to the second is 10 times 10, times 10 to the second, which is 10 times 10. How would you read this? It's 10 times 10 times 10 times 10, which is the same thing as what's up there. And 10 times 4, that equals 400, so that is wrong. So now we know equivalent, we can circle the equivalent expressions as well. Anyways, go ahead and try some problems on your own. Good luck.